So there are two key methods for transferring geometry between the CAD system and design modeler in Workbench. The first approach listed here is simply the direct import. So we take the geometry from the CAD system and we transfer it directly across to design modeler. Once we've transferred it across and the conversion has been applied, there's then no connection between the two systems. So it's a transfer, convert, and then it's then disassociated from the CAD system. We can then continue to work on the geometry within the design modeler through the simulation process. The second approach is to maintain connectivity between the upstream CAD system and the Workbench design modeler, such that if we make a change to the geometry in one or the other, then it's automatically updated in the other. So there's an automatic updating and connectivity between the two is maintained. And that's referred to as an associative interface and requires an additional plugin in order to maintain both of the geometries are up to date. So in this sense, it's a bidirectional connectivity as opposed to the first approach, which is the one-way or unidirectional. And it's also important to point out that the second approach here, this ANSYS Direct, requires a CAD interface, an improved interface in order to allow the sharing of information between the two systems. So the CAD connections and readers and interfaces are listed here. So when it says supported readers, as opposed to the plugins interfaces, the readers are the one-way transfer and the plugin interfaces are the associative or two-way transfer. So on the left-hand side here we can see the one-way transfer versions of CAD systems that are supported for one-way transfer, and on the right-hand side we can see the associative or two-way transfer versions of CAD that are supported. Now, of course, the ones the plugins or associative interfaces listed on the right-hand side of the screen also will support the one-way transfer. So if you just want to do a one-way transfer from the CAD system to design modeler, you can either use the readers or you can use the associative interfaces for that. It's only when you get to the point that you want to do two-way that you have to use these interfaces listed on the right-hand side. Okay, so as you can see, these are all the versions that are supported as far as the CAD versions that are listed, and typically some of the earlier versions may also be supported as well, but it's worth checking with your local support team or also in the user guide to check for more details if you're using different versions of CAD systems. So in order to bring the geometry in, as far as the first approach, which is the import and conversion process, we can use the import option from Workbench with file imports, as can be seen on the image on the top right here. So file import. We can also just right click on the geometry cell if we've already got that in the project schematic and elected here import geometry. So if it's we can then import it from that option and then select the geometry to be imported. And then directly from the design model session itself, we can simply go to File and drop down to Import External Geometry File, and we can choose a geometry or multiple geometries to be imported into the design modeler session. So these are the different ways in which we can import the geometry from a file, for example, that's been written out from the CAD system. As far as the second approach, which is the associative interface or the bidirectional CAD connectivity, we can launch Workbench in many cases directly from the CAD system. So here we have some drop-down menus that then appear after successful installation and configuration. We can see these ANSYS 14.5 and 14.0 drop-down options. So in this example, we would have Unigraphics, UGNX, open with the CAD system and the CAD model there, and then we would have these options here on the top right hand side of the drop downs from within UGNX, and we can drop down to ANSYS Workbench, and that will fire up Workbench and transfer the geometry directly over. And we have got some options for controlling the name selections to be transferred to Workbench as well. For bidirectional import from the DM session, we can, instead of going from the upstream to the downstream, we can actually go from the downstream design modeler and connect it back up to the upstream. So we can opt to file attached to active CAD geometry. So as long as the CAD system is up and running and it's visible to the design modeler, we can allow the design modeler to attach to that upstream CAD system, so we can then share the geometry. And it's also important to note about the parameter key as well as a prefix. There's a prefix for importing the parameters where we can specify here the parameter key. The default is DS, but we can edit that to anything we want, so that we can choose to, as a filter, as mentioned previously, we can choose as a filter which parameters are going to be transferred and maintained between design modeler and the CAD system by selecting these geometry preferences. And here we can see an example of the parameters allowing transfer for bidirectional or associated with the associative CAD interface. So on the left-hand side we have a CAD system. In this case it's shown as Pro Engineer, and we can see the parameters that have been created in order to define this particular geometry. So here we can see we've got number of holes 6 and a hole diameter as 3 mil, and these have been exposed of these particular types, in this case integer and real, and these can be selected from workbenches being exposed and visible and available for use in Design Modeler. So once these have been set up and we've set the parameters as described in the previous slide, we can then have these transferred from CAD to Workbench and make sure that they're available in Design Modeler. So here we can see those two numbers, 6 and 3, is available listed down here. And similarly, because we have the associative interface available here, because we've fired up Design Modeler directly from the CAD system in order to establish that connectivity, not only can we modify the parameters in the upstream CAD system here and have them reflected in the downstream Design Modeler, we can also update them in Design Modeler and have them pushed back upstream into Pro Engineer in this case, and have the geometry updated at the higher system here as well. We can also, in addition to parameters, we can also control the name selections as well, which are used to define bodies, which can be very important for setting up your analysis to define which zones are specific load zones or boundary conditions, for example. So they can also be defined in the CAD system and transferred to Workbench in a similar way to parameters. And they can be defined directly under Workbench as well. It's not necessary to define them only in the CAD system, and indeed we could combine them as well. So we could create some name selections in the CAD system, we could bring the geometry across into Workbench Design Modeler, and then we can create some additional name selections there if we needed to as well. Just as with DS for parameters, there's a default filter or prefix for name selections called NS, but we can edit this. You can see here the options for geometry import, name selections elected to say yes, bring in the name selections, and then you're filtering prefixes. If we want all of the name selections in, we can just drop this prefix back to blank, as we can see here, and that will bring all of the name selections in regardless of any prefixing. And here we can see an example, just as we saw with the parameters and the numbers being transferred. In a similar way, we can transfer the strings associated with name selections from the upstream CAD to the downstream Design Modeler Workbench. So here we have 3 name selections which have been generated. Now, of course, in the CAD system, they may not be referred to as name selections. They may be referred to as something else like publications or something like that, depending on the CAD system. But it's essentially just a string that's been associated with particular groups of, for example, surface bodies, and then once they've been established and associated with the geometry, they can be transferred and they will appear downstream in Design Modeler as name selection. So you can see under here, underneath the attach, we have the name selections identified with the particular names associated with them. So you'll be able to cross-reference those between the upstream CAD system and the downstream Design Modeler. There are some prerequisites for CAD Connections. So these are some of the things that you need in advance in order to bring geometry across, depending on the particular CAD system of interest. Now, depending on that particular CAD system that you have, it's important. It's useful to go in and find out a bit more about the necessary requirements to bring them over, because they do vary between different CAD systems. But for all CAD packages, you need the CAD system correctly installed and licensed, and also need the correct ANSYS license manager, ANSYS license, CAD connection license available as well. Now, if you're doing the one-way transfer, in some cases you won't need the upstream CAD system installed and licensed. You can bring in the geometry and allow it to convert directly. But for some of them, and also of course for the bidirectional and two-way, you will need the CAD system installed and licensed in order for the connectivity to be present between Workbench Design Modeler and the upstream CAD system. But we can list out here some of the for some of the key CAD packages here for CATIA, UGNX, some of the key requisites needed in order to maintain the connectivity. So here we can see, for example, for CATIA, if we take this first example, we need a compatible version of V5, which includes releases 17 through 18 up to 21, IBM LUM or DSLS configured with the CATIA V5 license, and we also need the CAD Nexus Capri Gateway, which is the associative two-way interface that sits between Design Modeler and the upstream CATIA interface. And that of course needs to be licensed as well as installed. So that gives you an example of some of the prerequisites. But I'd recommend going and looking in the documentation to view and understand the full prerequisite list for your particular CAD system. There's also some additional options to be aware of when transferring CAD systems as well, transferring information from CAD systems, and these need to be set correctly in order to ensure that the geometry and all of the information that you want to transfer with the geometry is transferred correctly. So it's necessary to make sure that you run down this list of advanced geometry options and select the necessary preferences as you deem suitable for that particular geometry. So whether you want to maintain associativity, import the CAD systems, import the work points that have been used to define the CAD, maybe you want those or don't want those to be transferred, and you can select all of these options in this drop-down option under Advanced Geometry Options. You can also select an important one here is Mixed Import Resolution. So if you have mixed dimensions, you can choose to bring those in if you need to as well.